So I'm just going to start over so I can record. So this is chapter 4, part 2, describing the relationship between two qualitative variables. So this data table represents the relationship between different levels of education and employment status for residents 25 or older in 2014. They call it a contingency table or a two-way table. We have a row variable and we have a column variable. The row variable is your employment status and your column variable is level of education. They refer to each of these boxes in the table as a cell, just in case you see that, kind of like you do when you're doing a Excel. They call it a cell. So we want to investigate whether the two variables are associated. For example, are individuals with a higher level of education more likely to be employed? So let's look at a couple questions that we might ask about a contingency table, looking at that table. How many people were employed high school graduates? So you would look for the level of education to be high school graduates and look for employed, and it would be 33,624. Or how many people were unemployed with a bachelor's degree or higher? So unemployed would be our second row. Bachelor's degree or higher would be our last column. So the answer would be 1615. So those are the kind of questions you can answer with a contingency table. The next thing we compute is the marginal distribution. The marginal distribution of a variable is a frequency or relative frequency distribution of either the row variable or the column variable in a contingency table. So to find the marginal distribution of the row variable, we find the total for the row for each of the rows. And to find a marginal distribution for the column variable, we find the total for each of the columns. So you can see it's done here. And the total we usually find too. So notice the total's 2008,720 of the whole distribution. You can find it either by adding up the total in the last column of the total column, or you can add the total across the bottom. You should get the same number because we're adding the same numbers. Okay. So let's look at a couple questions we can ask about marginal distribution. So how many people were included in this data? We can look at the total. So 208,720. How many people were employed? We can go across the employed row and get 128,744. How many did not finish high school? We can go to the first column and it's 24,395. Now it would be nice if we could do all this in StatCrunch where it could find those totals for you, and in fact we can. So as I do each new kind of distribution, I'm going to show you how to do it in StatCrunch as well. So here's the same data in StatCrunch. So I have employed, unemployed, not in the labor force, didn't finish high school grad, some college BA or higher. You can put it right, you can just type the numbers into StatCrunch. I have done it for you, so if you look at the top, this has been added to our group, our data set, employment and education level contingency. So if you just want to practice each of these things, you can see how to do it really easily in StatCrunch. So notice we're putting the categories across the top. or in the first column, because you can't change those row numbers. You just put it in the first column and leave that var1 as var1 for the first. And then in StatCrunch, if we want to find the total of all the columns and the total of the rows, what we can do is do tables, contingency with summary. Now, when you go into the next thing, you have to select your columns. So you have to select all the columns, not just one column. So you're going to use Control or Shift to make sure you get all the columns. And then for row, where are the row labels? You're going to look that I put them into where it said var1. So I chose var1 to say where are the labels. So you're choosing all the columns and you're choosing where are the row labels. Usually they'll be in var1, variable 1. And then when you click compute, it does the totals for you. So we get the totals of each column. Saves you a little time. So there's going to be a few homework problems where you have to find the totals, and you can have StatCrunch do it for you. The relative frequency marginal distribution you can do as well. So it's going to do the percents instead of the totals. Excuse me. So for example, it's going to total up the first column and then divide by the total 208,720 to give you a percent for each of the columns and a percent for each of the rows. So questions we can ask once we find the relative frequency marginal distribution: what proportion of people are unemployed? So rather than looking for the number of people that are unemployed, we're going to look for the proportion. So we could go to the unemployed row, and it's 0.031, so about 3%. Or what proportion did not finish high school? And we can go to that column and get 0.117. We can also do this in StatCrunch. It's the same contingency table process, but below you can also choose what kind of display you want. If you don't choose one of these, it'll do the frequency as we did earlier. But now if I want to do a percent of total, then it will do the percent of each one so that you can get the relative frequency distribution. Okay. And then you can also do something called a conditional distribution. The conditional distribution lists the relative frequency of each category or row given a specific value of the explanatory or column variable. So you're doing the response or row variable given the column variable. So if you notice when we did here in the relative frequency marginal distribution, we have a percentage in all of these rows and in all of these columns. But in this spot, we have a 1 because we're doing the total divided by the total. So we get 1. But looking at what we're doing now, let me clear that. We're just doing ones in the bottom. So we're dividing each column by the total of that column. And that's a conditional distribution where you divide by the column, which is the explanatory variable. So we divide by that column total. And that's a conditional distribution.
Could you repeat that again? Divide.
So when we were doing the frequency and the relative frequency, when we did the relative frequency, we divided by the total of the whole distribution. So I called it the total. It was the total of all the rows, total of all the columns. Whereas with this conditional distribution, we're dividing just by the total of each column. So for example, the total of all the did not finish high schools was 24,395. So we divided each of those by 24,395. The total of the high school graduates was 61,442. So we divided each of the high school graduate numbers by that total. Same thing with some college. We divide by the total of that column, and the bachelor's degree or higher, we divide by the total of that column. They call that a conditional distribution. So you divide each cell by the total of the column that it's in.
I get it now. Yep.
Okay. So what kind of questions do we ask for a conditional distribution? What proportion of individuals have some college and are unemployed? So have some college and are unemployed is going to be given by 0.034. What percentage of individuals are not in the labor force and did not finish high school? They're not in the labor force and didn't finish high school, so 54.4%. Well, let me write those answers in. Okay, so have some college and are unemployed would be 0.034. Not in the labor force and did not finish high school, 0.544. And to do that in StatCrunch, you can also find that conditional distribution by asking for a column percent. So the one we did before, where it was the relative frequency, we did the percent of the total, but now we're doing the column percent. And that's a conditional distribution. And that's kind of it for this section, is just to start looking at the different ways we can look at a data table that has this categorical data, where we're trying to look at, does one categorical variable predict another variable? And we're going to go look at that in chapter 11 and 12 a little bit. That's about it. The homework's pretty simple. There's 3 homework questions with a lot of little questions in them. And this will all of what we're doing right now prepares us for what we're going to do next week. Any questions?